Hello, this is Byounghyoun Woo, but you can call me Brian. Here in this video, I will show you two things. First, computational analysis of mathematical problems with the usage of Matlab and Simulink. Second, C programming and its implementation in an embedded system. Let me start.
I chose a spring system problem for my demonstration. Here is the problem. Please look at the problems for a while. In the system, there are three different types of forces. The first, exerted by the weight, air resistance, and the spring itself. And they add up to be 0. To be more specific, I changed the formula in this way. F becomes m times a. F prime becomes k times v. F2 prime becomes k prime times s. M is weight, k air resistance constant, k prime spring constant. Because acceleration is the derivative of velocity, following velocity, the derivative of position with respect to time. AMV can be rewritten in this way. So the equation becomes the following derivative equation. Constant k prime can be calculated in this way, even though it is not given in the problem. Now I have this equation. To solve this equation, I need to assume this. After a short computation, I get the solution, lambda. So, applying this lambda value, I have the solution for s. S is e to the negative 0.1 t times a cosine square root of 41 over 5t plus b times sine square root of 41 over 5t, which is with the ab as constant. Luckily, we have initial values, which means that we can get a and b. x0 is negative 2, x prime 0 is 0. Also, with a few computation, we get a is negative 2 and b is 1 over 2 square root of 41. So the final answer is this. Now we want to see how it looks like. I'm gonna plot this equation in Matlab. Now I will turn on the Matlab program here. Make a t as an independent variable. Let me say it starts from 0. The increment is 0.1, goes up to 50. And I don't want to see the whole bunch of response from Matlab, so I put semicolon at the end. Now I'm gonna write the whole equation I got. X is exponential negative 0.1 times t, and period times of the parenthesis negative 2 times cosine of square root of 41 divided by 5 times t, close it, plus 1 over 2 square root of 41 times sine of square root of 41 divided by 5 times t. Close it. I need one parenthesis and the semicolon 2. Okay, now plot it. Plot t comma x. As I expected here, it starts from negative 2 meters down from the balanced position and it oscillates, but the amplitude decreases with time. The amplitude decreases with time. Okay, now I am back in the PowerPoint file. Here is the differential equation, and I will take a Laplace transformation. In the Laplace transformation, d squared x over dt squared is s squared times x of s minus s times s0 minus s prime 0. And the dx over dt is s times x of s minus s0. And with a few computation, we have transfer functions for the system. I'm gonna put this transfer function in the Simulink. I will go back to Matlab and launch Simulink. Okay, find new model. Expand the window a little bit. Because I want to use transfer function, first choose the transfer function control. Double click it. The numerator was 10s plus 2, so 10 space 2, and the denominator 5s squared plus s plus 25. Click OK. Also, we want to see the results, so I need a scope control. Scope is currently used plus. Yeah, here, scope. Connect them. Here, also we need to input for the action of stretching of the spring. However, we don't have the exact input for the action. In the Simulink, most of the input is kind of continuous rather than one-time stretching. To simulate this system, I chose a step input for the second best option. So step, oh yeah, here. It starts -2 at the beginning and it becomes 0 at the end. Click OK. Now connect them. I want to extend the time almost like 50 seconds. Okay, now it was fine. Start simulation. And let's see the results. Because the step function is not exactly the same with the action of stretching a spring, so it is a little different, but I think it looks close enough with the first plot. Now we go to C++ program and the implementation of embedded system. First, open Visual Studio. I already installed OpenCV library and also typed a simple C code because of time constraint. Let me explain the code. Here, I set up some variable for image and webcam. Also set up Windows. Its name is OpenCV Test. The size is 640 times 480. It goes in the while loop. In the while loop, there is a CV grab frame, and it gets a frame from webcam, and in the retrieve frame, it saves images in the variable image variable, and also it attaches the image to the windows. And this process goes on and on. It never stops. But if you press ESC key, 27 is ASCII code for ESC key, then it breaks. It goes out of the while loop. And here, release means release the resources for webcam and image and destroy all windows. Then the program stops. Let me start the program. Okay, here is the images from webcam. Now, this is my computer, and you can see the screen from webcam, and this webcam is attached to this computer. Now, this is my embedded system. The name is Cubitron, and several peripheral keyboards, monitor is attached to this embedded system. I will connect this webcam to this embedded system. Let's see what will happen. Okay, I confirmed that the code was fine. Now I am going to unplug the webcam and plug it in the embedded system. To control the embedded system remotely, I run the WinSCP. The IP address for Kavitrak is 192.168.0.82. Protocol is SCP, Renaro, password, and login. That looks good. The left side is my host computer. This is a remote system, Kavitrak, I mean. And my code process OpenCV is here. I need to copy this to download thread and drop it. Copy. Okay, now the code is in the embedded system. I need to compile this code in the Kavitrak. So actually here. Actually, I installed the whole OpenCV and the G++ and the Kavitrak already because I don't waste my time. G++ test 0422.cpp minus my output name is let me say OpenCV test, and also I need to include the whole bunch of OpenCV library. So C flags, libs, and OpenCV and closing. Execute. Okay, error message unknown options. Okay, maybe there's 2 minus. Okay, start again. I think that was fine. Okay, now I have a SQL file, but here, the program, the SQL program, the file includes graphic interface, but the graphical interface is not shown remotely. So I go locally. I mean, I gonna attach the keyboard's monitor to the embedded system, and I'm going to show you the screen, the images from the webcam, which is attached to embedded system. To show that, I'll run webcam program one more time. Here, run it. For some reason, I don't have enough multiplier. Okay. I turn my laptop to here to show you the screen which is attached to Capital, and I'm gonna type the and run the program here. ls, yeah, okay. My OpenCV test is there. Enter. Now here's the webcam. Can you set up? So this is the webcam where this is attached to the Capital. Can you set up? The USB webcam, the black one. Okay. This is it for my demonstration. Thank you for watching.